Hello students, hope you all are doing well. Here in this video, we are going to talk about another type of bonding. For this time, we are going to talk about the ionic bonding. It's under the unit bonding and structure. So far, we have finished talking about covalent bonding. Students, what are bonding? Atoms, they form bonding to form structures. So, when atoms exist out there, you could find those forming compounds, various structures. Then those structures could be named as either molecules or lattices. Then students, those molecules, lattices, atoms, they form those through bonding. They form bonding. Then atoms, when atoms form those bondings, you could find out two major types of bonding formed by those atoms. So, first type is the strongest. We call them primary bonding. Second type, when you talk about those units, the attractions those units are having, their interactions, we call them the secondary bonding. Those are not that strong as much as of this primary type. Okay, so we have primary bonding, secondary bonding, strong bonding, quite weak attractions. We call this primary bonding intramolecular bonding, and these attractions intermolecular attraction forces. Then within those intramolecular bonding or primary bonding, you have three types: covalent, ionic and metallic. It's already we have finished talking about the covalent bonding. Then students, this effort here in this video we put towards ionic bonding. We are going to find that out what are ionic bonding and why atoms they form ionic bonding. What are ionic bonding? Students, it's in your O level, even in your O level, it's you have learned. I guess that you have got your idea regarding what are ionic bonding from your O level. There, you might have learned already that ionic bondings are evolved between two oppositely charged ions. So it's the same here even in A11. Students, you need to have two opposite charges. Two oppositely charged actually ions here. What are the two oppositely charged ions? They are cations, anions. Positive ions, negative ions. When you bring a positive ion, positively charged ion, close by a negatively charged ion, what would happen? What else it could happen? They would get attracted. Those are the electrostatic attractions evolve. Attraction forces evolve. Students, the electrostatic attraction forces that evolve between two oppositely charged ions is referred as an ionic bonding. Okay, let me show you briefly. This is a circle. When it is a sphere, when it is an atom, when it has lost one electron, it is one of few electrons, it's possible. It is positively charged. It could be, with respect to the number of electrons lost, it could be 1, unipositive, 1 plus charge. When one electron is removed by an atom, it could be 2 plus, 2 positive, dipositive, 2 electrons removed by an atom, 3 plus, tripositive. So it could be any such number of electrons removed. Then accordingly there would be a positive charge. Then students, this positively charged ion, it's a cation now. Then it would get attracted towards the other type. What's the other type? Other type is a negatively charged ion. It could be a uninegative ion. gaining one electron atom could form an anion with -1 the charge. We call them uninegative anion. So it could be taking 2 electrons, it could be dinegative or 2- ion, 3-. Such anions also possible. So then students, a cation you have and anion you have. They are two opposite charges, oppositely charged species, oppositely charged ions. These two ions will attract each other. We call that an ionic bonding. So when they come close, there will be an attraction involving here between positive and negative ions. These electrostatic attraction force here is referred as an ionic bond. Ionic bond it is. Okay. So if I ask you for an example standing for an ionic bonding or ionic compound, what would you reply with? Let me guess. It is sodium chloride. Okay. Most of students first come with sodium chloride. So most of people, let's say not most of students, all. So most of people, they get this compound as the very first example standing for ionic compound. It's quite like the national ionic compound. If it is an ionic compound, it's sodium chloride. Anyway, so let's take the same. It's sodium chloride I'm now going to talk about. Sodium chloride is having the cation sodium plus, and the anion chloride Cl minus. This cation would get attracted towards the anion. That electrostatic attraction is the ionic bonding. It's that easy. It's very easy. Then students, it's for some reasons, some students they start with this. Sodium, they are loses an electron as to form Na plus, means unipositive cation. Chlorine gains that electron as to form Cl minus, means uninegative cation. Then they form the ionic bonding. So it's nothing wrong with that, but students, the question is that a must always the same sodium needs to give the electron on chlorine to become negative? My point is, if it is sodium chloride you get, is that a must? This electron sodium removes to be taken by chloride close to that as to form Cl minus. Think. Anyway, purposely, consciously or not unconsciously, we are having that attitude as well. It's not that good. So anyway, sodium at any place at a time, being an atom sodium would lose its electron, would lose an electron. For the reason, sodium is having 11 protons and 11 electrons. Then students, it is those 11 electrons are kept like 2 electrons, 8 electrons in the second shell and 1 electron in its outermost shell. So this 1 electron in its outermost shell would be removed as to show its second shell as the outermost shell then after. So atoms, they would be stable in electronic configurations when they have 8 the number of electrons in their outermost shell, because it's fully filled then. Having fully filled shells, having fully filled outermost shells, those atoms would become stable. Therefore, when it is about metals, they have lesser number of electrons in their current outermost shell, so they would lose all those electrons. They have a tendency as to lose those electrons to reach octaves to show the inner shell as the outer shell now. Then sodium would lose one electron as to become Na plus. So this is sodium plus Na plus is having 2 electrons and 8 electrons only. The last shell's electron is there, has removed. Then chlorine is having 17 electrons and 17 protons. So 17 electrons could be named as 7 electrons in the outermost, 8 in the second and 2 in the first. Then chlorine is very close to reach 8 octave. So then this chlorine would gain this electron, becoming an octave in its outermost shell. 2 electrons, 8 electrons and 8 electrons. Anyway, what I was telling earlier, it is not a must when we talk about ionic bonding, it is not a must this sodium to lose an electron at the moment when they form the ionic bonding. It's then that electron to be taken by chlorine at the moment to become a Cl minus. It's not a must. My point is, they shouldn't react. They mustn't. Or it's not a must. It's no need for them to react at the moment as Cl and Na meeting each other, giving one electron on Cl by Na, becoming a cation, making it into an anion, then they attract each other. It's not a must. It also possible. It could be meeting sodium with chlorine, they could react as to form sodium chloride. But students, it's possible in this way as well. Already formed Na plus cation and already formed Cl minus anion. When you bring them close, they will get attracted. So, regardless of the fact how this cation and anions were formed, like regardless of the fact whether it is sodium has given electron on the same chlorine or not, it's anyway, if you get Na plus and if you get Cl minus, and if they attract each other, then that electrostatic attraction force is the ionic bonding between sodium and chlorine, sodium cation and chloride anion. So then this is how, when they form their cations and anions, this is how they form their cations and anions. It's possible chlorine to gain an electron from somewhere else as well. Another source, some other source also. It's possible. You can't limit it, and you can't say that so chlorine must gain the electron given by sodium or something. It's a misunderstanding if you are having. Anyway, simply the ionic bonding is the electrostatic attraction force evolved between these two oppositely charged ions. Okay, that's it. Then students, between some atoms, we always, all the time, get ionic bonding like sodium chloride. Between some other atoms, at all the times, we get not ion but covalent bonding. Then what's this? What's this difference is made by? Students, why is that? Why is that some atoms always form covalent bonding while some other atoms they form ionic bonding? What's the reason? What's the reason for this difference? So, if those atoms would ask why always me forming covalent or other way, forming ionic bonding? Why can't I behave as of others? Like, wouldn't I get the freedom as to form whatever the bond I could form? Means whatever the bond I want to form. On that matter, answering that matter, that problem, if you are going to use this concept called electronegativity. Students, you already might have heard of this word electronegativity. They are in very first unit. Talking about the electronegativity, you might have compared their electronegativities of various elements. Then, though this is the best place apply the concept electronegativity. The concept electronegativity was introduced on this purpose. Which purpose? The purpose is why is that some atoms are forming covalent bonding while some other atoms are forming ionic bonding. Okay, then let's check that out. Before checking that out, you need to know the concept clearly. What's the concept? It's the electronegativity. Students, electronegativity is when those atoms form a bonding. Let's say sharing electrons, when they form a covalent bonding. So they both would agree as to share electrons. They would have talked each other. You give yours, I will be giving mine. Let's share our electrons. Let's overlap our atomic orbital as to form orbitals, as to form the molecular orbital. So they are planning their future. So you give your atomic orbital with the electron, I will give mine. Let's overlap our atomic orbital. Then after we will be having those two electrons kept inside. This common orbital is the molecular orbital. Then we will share those two electrons there inside the molecular orbital. It is overlapping atomic orbitals. A molecular orbital would be having, it would be formed. Then the electrons in the molecular orbital. Then it would, this molecular orbital electrons would attract this nucleus as well as this nucleus. So that's the covalent bonding. Anyway, the concept electronegativity is the other way. When there is a covalent bond formed, this, though they negotiate each other, though they talk each other, though they agree, as you give yours, I will be giving mine, let's share or something. After the formation of covalent bond, after the overlapping of their atomic orbital, by the very next time, thereon, each atom's nuclei would, this nucleus having protons, would start attracting it in its direction and the other also. So students, the point is, when atoms they share electrons overlapping their atomic orbitals forming molecular orbital, by the very next time they would start drawing that bond electron cloud towards their nuclei. So though it appears like sharing, they have this cold war between those nuclei. Each nucleus would try to draw that electron cloud towards their nuclei. This is referred as the electronegativity. Students, it's the ability or affinity to attract the bond electron cloud towards their nucleus, towards the nucleus of an atom, is the electronegativity. So we have talked enough about electronegativity, but this is the best place, or this is the place they introduced the concept electronegativity to explain how some atoms form covalent bonding while some other atoms form ionic bonding. So talking about this concept electronegativity, we found out different atoms are capable differently of drawing this electron cloud in the bonding towards their nuclei. So its different atoms are having different electronegativities. When it increases the number of protons found in the nucleus, as well as when you find the radius being less, with having such means with increase of the number of protons in the nucleus, with decrease of the radius when it goes close the nucleus, the electronegativity of an element would get increased. You would expect great electronegativities from those elements having low radii and more protons. when it goes left to right through the periodic table, at the rightmost end, you would find, rightmost top, you would find the greatest electronegative element. What is that? Students, it's nothing else but fluorine. Fluorine is the strongest or greatest in electronegativity. When it goes left and bottom, so it is leftmost bottom of the periodic table, it's francium having the least electronegativity. So then you could compare those electronegativities assigned or comparatively, you could state the electronegativities of those elements. It is Linus Pauling has presented a scale standing for these values, these electronegativity values. Okay. So according to Pauling's scale, the maximum fluorine is assigned with the electronegativity 4.0. Then the minimum is francium is assigned with 0.7. The electronegativity of those elements. So when you check for some others, it's fungal, you could give the topmost electronegative elements. First, most electronegative is fluorine. It takes 4.0, 3.5, 3.0. Here also 3.0. But compared to chlorine, nitrogen would be more electronegative. Anyway, students, we are now going to apply this concept electronegativity to explain, describe how and why some atoms form covalent bonding only, while some other atoms form ionic bonding only. Okay, so I am going to take these as the examples. Chlorine Cl2, it is CCl4, it is HCl and NaCl. Let's talk about these as examples. Then students, you might already know what kind of compound molecule is that, and this and this. And then you might already could recognize whether it is covalent or ion. Then shall we forget those all? Like, let's start thinking these all if they were covalent, something like that. Let's start thinking these all the compounds, all are molecules, covalent molecules, but with the covalent bonding. And let's find it out the reason for some are not covalent while some others are covalent. Okay, so I'm telling or giving you the chance to name them all covalent. Give the bonding with a single line. Okay, I hope you are ready. On that, it's HCl is having a covalent bonding, and NaCl for this example talking about kind of their electronegativities to show that how it affects these electronegativities. It's deciding or determining covalent and ionic character of a bonding. It's, let's say, NaCl also as a covalent substance for this moment only. Okay, students. Then after, let's assign those values we already know regarding their electronegativities. Its chlorine is having 3.0, 3.0, 3.0, 3.0 and 3.0 there as well. Then after, it's you have carbon having 2.5, hydrogen 2.1, 1.0 are the electronegativities. Then let's give their differences. It's 0, it's 0.5, it's 0.9 and it's 2.0. Those are the electronegativity differences. Then students, when they have shared electrons, when there is no electronegativity difference, that bond electron will be kept between those two atoms symmetrically. So this electron cloud in the bonding would not move much towards any atom. So therefore it remains symmetrically. That's the 100% covalent type. Means it has not moved excessively towards any atom. That's the best time to have a covalent bonding. That's the best interpretation or best definition standing for covalent bonding. That's the best time that they share electrons. That's the 100% of perfect covalent moment. So you could call this the perfect covalent bonding. Perfect covalent bonding, or 100% covalent bonding, or non-polar covalent bonding. So it is, let's say, perfect covalent bonding. Okay, then students, here you have a slight difference of this electronegativity between carbon and chlorine. So chlorine there is more electronegative. Therefore, this bond electron cloud would shift towards chlorine than carbon. It's not much, but it's not symmetric now. So for that reason, it's not symmetric as much as of this. It's therefore carbon experience removal of, or it's not completely, it's partially losing of electrons. It's therefore we assign slight positive, slight negative, two charges. Means, students, within that covalent bonding you have an electron cloud. That one electron cloud goes more or drawn more by chlorine. Towards chlorine this shifts. Therefore, it seems like chlorine is now gaining an electron. If it is one electron gaining, you would name it as -1, the charge. But it has not gained totally the electron from carbon. It has drawn bit more, means greater than of that carbon. It's slightly more electronegative. Therefore, it could take that electron cloud bit only. So, if -1 is representing gain of one electron, this could be given with just a piece of that -1. It's we call a dipole. It's a dipole. So students, you would get here a slight negative dipole, there a slight positive dipole. So therefore, thereafter, this bonding is referred as a polar covalent. Okay, let's go to the next. Student, regarding this bond electron cloud, there also you have an electronegativity difference. But compared to earlier, now it's quite greater than of earlier. Therefore, this hydrogen would be threatened by chlorine as they both would draw their electrons in the bonding. But chlorine is more electronegative than hydrogen. It draws this bond electron cloud more towards chlorine. Therefore, this poor hydrogen is going to lose its electron. It's at the risk of losing electron. Therefore, if we assign slight positive, slight negative, two charges. Compared to this, now the piece is quite greater than of earlier. Students, if it is -1, the charge you get of gaining one electron, now it is quite big piece that it responsible or it gives this slight negativity. Okay, so it's a dipole. This dipole is quite stronger than of earlier dipole. The bond has polarized. It's a permanent dipole you get there. So it's a polar covalent bonding you get there. That also could call polar covalent bonding. Polar covalent. Then students, it's when the electronegativity difference increases further, then this polarity would get increased. one atom would draw, one atom's nucleus would draw it more and more and more. So the bond electron cloud would shift more and more and more towards that atom who is greater in electronegativity. Therefore, shifting, there will be a moment as whole electron cloud would be removed by one atom. When the electronegativity difference is very high, the electron cloud would completely removed by one atom and other atom would take it completely. Without the support of environment, it could be said as when it is 2.0, the electronegativity difference, it would reach 50% of covalent and 50% of ionic, the character. After increase of this electronegativity difference further, it would fully separate into two ions. Anyway, in NaCl, it's now enough, this difference, as to separate the bond electron cloud fully. Into Na+, this Na would lose its electron and Cl would gain that electron completely. They would become Na+ and Cl- having that high electronegativity difference. That's the reason. So, then after separation of the bond electron cloud fully, now there are two oppositely charged ions. Anyway, two opposite charges, they get attract each other. Therefore, this electrostatic attraction force is the ionic bonding. That's it. That's the answer. Students, it's the answer for the question why. Why is that? Why is that? Some atoms form covalent bonding only, while some and other atoms form ionic bonding only. It's the electronegativity difference. When you have no electronegativity difference, the bond would be 100% covalent, perfect covalent. Then, having that electronegativity difference, this bond electron cloud would shift towards more electronegative atom. So, with increase of the electronegativity difference, it would shift more and more and more, giving more polar character. After having such an electronegativity difference, it would be polarized. We call them dipoles. So, the bond is a polar covalent thereafter. So, this also polar covalent, but the polarity here having great electronegativity difference than of earlier would be greater. So, the polar character would be greater. Then increasing, further increasing. This electronegativity difference causes it to remove completely the electron from sodium, and other one to gain that completely. So those would get transformed into positive and negative ions, cations and anions. So students, with increase of electronegativity difference, there would be an increase of polarity. So the extreme of that separate those into ions. Then you would get nothing else but positive and negative charged ion or cations and anions. They will be attracted each other, so they do not have the luck or chance as to stay there still covalently. For that reason, it is NaCl all the times, and all the times it's an ionic substance. So, when it goes left to right, according to these examples, students, it's their electronegativity difference with increase of that, their covalent character decreases and ionic character increases. That's what it happens. So then this is 100% covalent, perfect covalent, this is polar covalent, this is polar covalent, and that one is ionic. So when you compare each other, this is more ionic than this, this is more ionic than this is more ionic than that. So you could compare those covalent compounds each other as whether it's more ionic or less ionic. So here we call them polar covalent, this bond only. When you have such polar covalent bonds distributed throughout molecule symmetrically, as here it is CH4, the CCl4, we are going to learn that later on as it will distribute in the space tetrahedrally. Then students, if those polarities or polar covalent bonding, they are asymmetric distribution, different distribution is cancelled off throughout the molecule, within the molecule. Though you have it being a polar covalent, all the bonds would be polar covalent, they would arrange in the three-dimensional space symmetrically, cancelling the net result. Therefore, though this bond is a polar covalent, whole molecule would be non-polar. It's we are going to learn soon in our future lesson. Anyway, hope it's very clear now the point that some form covalent bonding, some others form ionic bonding. You would use the concept electronegativity to explain that. Using electronegativity difference, you could explain the fact why some are forming covalent bonding, some other atoms deserve ionic bond formation. Okay, students, hope these few points are clear to you. These are actually very simple few points. Okay, our next topic is the next primary type of bonding is metallic bonding. If we are going to talk about the metallic bonding in our next video, coming video regarding bonding and structure. Then students, if you find any difficult point or if any part being not clear, or if you have any problem to ask, if you could ask your problem, state your problem there underneath. You have that comment box, so you could send us those comments. So okay, anyway students, if you are going to round up here in this video with the hope to meet you in our next video, future video, talking about the metallic bonding. Okay, it's goodbye.